So far, we've seen addition reactions. And in these addition reactions, we had a double bond, and it reacted with some kind of electrophile, something that was electron poor. It could have been an acid, it could have been a halogen, but not the benzene ring, but the pi bond was your nucleophile. And it reacted with an electrophile. And we did addition reactions on this specifically. These were called electrophilic additions. And they're electrophilic additions because what we are adding to the pi bond is an electrophile. So these are electrophilic additions. Now we're going to turn the tables around a little bit. Now we're going to have pi bonds that we're going to attack with nucleophiles. So the pi bond is going to be an electrophile. Now we don't typically do this with carbon-carbon pi bonds. Instead, we're going to do this with carbon-oxygen pi bonds. So carbon-oxygen pi bonds are polarized. We have a partial positive charge on that carbon, and that makes the carbon an electrophile. What do we naturally pair up with our electrophile? Some kind of nucleophile. And so the nucleophile, the picture is getting kind of a mess, is going to attack the carbonyl and push the electron density up on oxygen. So this is the general idea that we're going to have with carbonyl reactivity. Again, these are going to be addition reactions. What kind of additions? They are nucleophilic additions. Okay, so in general, I'm going to put these in two categories. A regular carbonyl is indeed polarized, and we have a partial positive charge on the carbon, but this is still just a weak electrophile. So in order to react with a weak electrophile, what do we need? We're going to need a strong nucleophile. Now when I say strong nucleophile, you probably think, oh yeah, we talked about strong nucleophiles. It's all those SN2 nucleophiles. Kind of, okay? When we talk about nucleophiles, we need to be specific about the context. So as it turns out, our old best SN2 nucleophiles like azide and cyanide are not quite so good here. But we'll see how to define a strong nucleophile later. But just have it in your mind that to react with a weak electrophile, in general, we need a strong nucleophile. There's another thing that we will do, and this will be later on. We're going to take carbonyl compounds and we're going to react them with some acid. Now I'm just going to show H3O plus here. Strong acids will protonate the carbonyl. And now we've made this carbonyl really electron poor. And so this is actually no longer a weak electrophile, it is a strong electrophile. And so in the case where we use acid to activate the carbonyl to make it more electrophilic, we can actually use weak nucleophiles which may or may not be positive or negatively charged to react with our strong electrophile. Now we're going to start, for most of the course, we will talk about strong nucleophiles. But towards the end of the course, we're going to sneak in some strongly electrophilic carbonyls and we'll react them with weak nucleophiles. But that'll be later on. Right now, we're going to stick with strong nucleophiles.